Ever get that feeling like, things aren't as solid and permanent as they seem?
Yeah.
Well, that's kind of where we're headed today with this deep dive. We're looking at this article, just came out on February 3rd, 2025, and the title really caught my eye. Ancient Oceanic Plate Rips Apart Beneath Iraq and Iran.
Oh.
Yeah, pretty dramatic, right? And we're going to try to unpack how the Zagros Mountains are actually reshaping the Earth in ways you wouldn't believe.
Yeah, it's amazing the things we just don't see happening every day. This research really shows you the power of these hidden geological forces. We always think of mountains as these forever things.
Right.
But they're always working, changing the Earth, even way down deep.
So, what's the big deal here? What did they actually find?
Well, the Zagros Mountains, they're not just sitting there looking pretty. I mean, they are beautiful, but all that weight, it's literally bending the Earth's surface down,
right,
creating this huge depression.
Okay, so I'm picturing a hand pressing into clay. The mountain range is the hand?
Yeah, kind of like that. But what's really wild is the size of this depression.
Right.
It's massive.
Yeah.
Filled with, get this, 3 to 4 kilometers of sediment. And it's been building up for 15 million years.
Wow. But there's a twist, right? There's got to be something else going on.
Exactly. It's way too deep to be just from the mountains pushing down. There's something else at play here. Okay,
so what is it? What's pulling things down?
Okay, so picture this. A chunk of the ancient Neotethys oceanic plate.
Oh, what?
The Neotethys. It was this huge ocean millions of years ago between the Arabian and Eurasian continents.
Oh, right, right.
As those continents got closer, the ocean got squeezed, right? Forced under the Eurasian plate.
Okay.
So what we're seeing now is a leftover piece of that ancient ocean floor. It's still sinking, and it's dragging everything down with it.
So the mountains are sinking because of a ghost ocean? That's wild.
Yeah, pretty much. And the evidence is right there. The depression at its deepest where the plate's still attached. But over near Turkey, where it's broken off, the land's springing back up.
So it's like this tug of war, mountains pushing down, this ancient ocean floor pulling even harder.
Exactly.
So much going on under a mountain range. Who knew?
Right. You just never know what's happening beneath the surface.
Okay, so this is all super cool, but what does it mean for us up here? What's the practical side of all this?
Good question. The researchers, they think this whole sinking plate thing, it could change how we think about finding resources, and even predicting earthquakes.
Wait, hold on. What kind of resources? And how does a sinking plate, connect to earthquakes?
So this sinking action, it creates these things called sedimentary basins.
Right.
Prime spots for ore deposits to form. We could be talking iron, copper, maybe even precious metals. Like a hidden treasure chest under the mountains.
Wow. So the mountains are sinking, and they might be full of treasure. That's incredible. What about earthquakes, though? How does that fit in?
Well, all this movement, these huge plates pushing and pulling, that's what causes earthquakes. So if we understand how these plates are behaving, it can help us predict where earthquakes might happen, maybe even how strong they'll be.
So this isn't just ancient history. This research has real implications for today. Resource management, disaster preparedness, all that.
Definitely.
This is way more than just, rocks and dirt. But let's get into the specifics. How would we even get at those ore deposits? What are the challenges there?
Yeah, it's not like we can just, go digging a hole and strike gold. These deposits, they're probably way down there, formed over, eons. Minerals carried in by water, all settled out in layers.
So how do we even know they're there? What kind of detective work do they have to do to find these ore deposits?
That's where the real fun starts.
Yeah.
Geologists, they've got all these cool tools, seismic surveys. That's where they use sound waves to map out what's under the ground. And they can analyze rock samples too, see what's in them.
Right.
Might even have to drill some exploratory wells. Get a real close look at the rocks, see if there's anything worthwhile down there.
Yeah, I bet that's a big job. Especially in the Zagros Mountains. I mean, it's not exactly easy terrain.
For sure. And then there's the whole environmental side of things. Mining, even when it's done carefully, responsibly, it can still impact the environment. Got to find that balance, right, between getting those resources and protecting the planet.
Yeah, absolutely. Sounds like any mining here would need a lot of planning, making sure it's done sustainably. But what about the geothermal energy? How does that tie into the sinking plate thing?
Okay, so as that piece of the Neotethys plate goes down deeper and deeper, it gets super hot, crazy hot. The pressure builds up too.
Oh, wow.
And that heat, it can travel up, through cracks in the Earth's crust. So we can tap into those hot spots. We could potentially generate electricity.
So it's like the Earth itself is giving us clean energy. That's pretty amazing.
Right. And geothermal energy, it's renewable, so we don't have to worry about it running out. Plus, way less greenhouse gases than burning fossil fuels.
Right.
Much cleaner.
Yeah, that sounds super promising, especially with everything going on with climate change. But I guess geothermal has its own challenges, right? Nothing's perfect.
You got it. Geothermal power plants, they cost a lot to build. And finding the right spots, the geology has to be just right. You need good heat flow, and the rocks have to be permeable so you can get to the hot water or steam that drives the turbines.
So even though the plate is generating heat, it's not always easy to get to it.
Exactly. And then there's always some environmental impact. Geothermal fluids, they can release gases and minerals, stuff like that. It's not as bad as fossil fuels, but still something to keep in mind.
So it seems like there's always this trade-off, isn't there? Weighing the benefits against the risks.
For sure. And that's where the research comes in. The more we understand about what's going on down there, the better we can develop technology that's sustainable, gets the most out of those resources without messing things up too much.
This research is really eye-opening, I never thought about how connected everything is. Like, a sinking plate can affect everything from the mountains to the resources we use, even how we produce energy.
It shows you we're all part of this big system. From the highest peak to the deepest ocean trench, it's all connected. And the more we know about those connections, the better we can take care of this planet.
Speaking of connections, the article also mentions that the plate's not just sinking, it's tearing apart too. What's the story there? What does that mean for everything else that's going on?
Oh yeah, they found evidence of this horizontal tearing. Pretty wild stuff. So as the plate goes deeper, the conditions get more and more extreme, like crazy heat and pressure. And eventually the plate just can't take it anymore. It starts to crack.
So like a giant crack opening up under the mountains.
Yeah, something like that. Yeah. And that tearing, it can change things, like why the depression is deeper in some spots than others. Where the plate's still whole, it pulls down harder, right? But where it's broken off, the land can start to rise up again.
Wow, it's amazing to think about these forces, reshaping everything so slowly, but so powerfully. It's hard to wrap your head around it.
It's a slow dance, but a powerful one.
Yeah.
And this tearing, it throws another wrench in the works. It changes how the stress is distributed in the crust, which could affect earthquakes, and where those geothermal hotspots are.
So not just a sinking plate, now it's a sinking tearing plate. This is getting more and more complicated. But does it make a difference for the people who live there? Is it more dangerous now?
It's a good question. This tearing, it could create weak spots in the crust, could make earthquakes more likely. So it's something scientists need to watch closely, factor that into their risk assessments.
It sounds like this research has just opened a whole new can of worms, It's not just about the Zagros Mountains anymore. It's about all the other places where this might be happening.
Definitely. This study, it shows us just how dynamic the Earth really is and how much we still don't know. Every new discovery leads to more questions, more mysteries to solve. It's exciting.
Well, this deep dive has definitely changed how I see things. I'll never look at a mountain the same way again. But before we wrap up, let's go back to those practical implications we were talking about. You mentioned resource exploration, earthquake prediction, energy production. How does this all tie together? It's wild to think that all this stuff happening way down there under the Zagros Mountains could have such a big impact on us up here. Let's talk about those resources, the ore deposits. Is it really possible to get to them?
Yeah, that's the big question, isn't it? I mean, first you got to find them, and that means a lot of work. Geological surveys, seismic imaging, probably a lot of drilling too. And that's just to figure out what's there, actually getting this stuff out.
Yeah.
That's a whole other challenge.
Yeah, I can imagine. The terrain, the depth, it all sounds pretty complicated. And expensive, probably.
For sure. And then you got to factor in the environment.
Yep.
Any mining operation, you got to make sure it's done right, Minimize the impact on the ecosystem. It's a tough balance trying to get those resources without messing things up.
Right, got to be sustainable. So maybe not time to invest in Zagros Mountain mining stock just yet.
Probably not. But let's talk about the earthquake thing. How does this research help us predict earthquakes exactly?
Yeah, you said it could help. How does that work?
Okay, so these tectonic plates, they're always moving, right? Pushing and pulling on each other.
Yeah.
And that creates stress in the Earth's crust. By studying how these plates are moving, we can see where that stress is building up.
Okay.
And that gives us clues about where earthquakes might happen and maybe even how big they'll be.
So it's like we can see the forces that cause earthquakes.
Kinda, yeah. Of course, it's not perfect. We can't say exactly when or where an earthquake will hit. But the more we know about the geology, the better we can understand the risks.
Right, that makes sense, especially in a place like that where earthquakes are already a problem. But let's talk about energy, geothermal energy. How do we actually get it from a sinking plate?
All right, so picture this. That plate is sinking, going deeper and deeper, right?
Yeah.
The deeper it goes, the hotter it gets. All that heat, it could build up under the Earth's surface, trapped in these pockets of hot water or steam. And if we can drill into those pockets, we can use that heat to make electricity.
Wow. So we're using the Earth's own heat to power our homes, our cities. That's amazing.
Yeah, it's pretty cool. Geothermal energy, it's renewable, so it's not going to run out like fossil fuels. And it's way cleaner, a lot less pollution.
Sounds like a win-win. But I'm guessing there are some downsides too, right?
Well, yeah, there are always challenges. Building those power plants, that takes a lot of money and resources. And you have to find the right spots, places where the geology is just right. You need enough heat, and the rocks have to be permeable so you can get to that hot water or steam.
So even though the heat's there, it's not always easy to tap into it.
Nope. And there's always some environmental impact, just like with anything else. Those geothermal fluids, they can release stuff into the environment, gases and minerals. We got to manage that carefully.
Right, back to that balancing act. Benefits and risks.
Exactly. That's the key takeaway here, I think. The Earth, it's this incredibly complex system. Everything's connected. What we do in one place, it can affect everything else. We got to be smart about how we use the Earth's resources, make sure there's something left for the future.
Well, this deep dive has been a real eye-opener. I've learned so much about what's happening beneath the surface, how it shapes everything around us. I'll never look at a mountain the same way again.
Me neither. It makes you realize even something as solid as a mountain, it's always changing, always in motion. And what happens down below, it can have a huge impact on our lives, even if we don't see it.
This research, it's amazing, really. Who would have thought that a sinking, tearing plate under the Zagros Mountains could be so fascinating and so important?
Right. It just goes to show there's always more to discover. The Earth is full of mysteries, just waiting to be uncovered.
Well, on that note, I think we'll wrap things up for today. Thanks for joining us on this incredible journey beneath the surface. We'll see you next time for another deep dive into the fascinating world around us.